They ask us for quality. What is quality? Well, free of defects. It's a lot more than that. What's a defect? Well, when it doesn't work as we expect, as we agreed it should. Trust me, you didn't specify how the software works. That's my job. I'm a developer. I take all that what and all that how, and I crunch it down and I make it so specific that it can be done without thought, done by a machine. Programming is hard, but that's only the beginning, because you want more than that user story. You want user experience. You want the software to be up. You want it responsive. You want it clear and pretty and fast enough and doing enough things at the same time and integrating smoothly with all the other software. And then there's all the things you don't want it to do. Don't show my data to anyone but me. Don't do useless work. Don't get inconsistent no matter what the input. Quality is doing all these unnamed things and not doing all these other unnamed things. Software is hard, yet that's only the middle. Because next week, you'll want me to change it again. You'll want this feature to do something new while every other feature ever mentioned or never mentioned holds still. Meanwhile, the technology underneath the system is changing, it's updating, it's upgrading, and I need to move with that. Quality is continual change. Software development is hard. How are we supposed to do all this? How are we supposed to keep all of this straight and at that incredible level of specificity for a machine? Engineering discipline, clean code, test-driven development, refactoring, functional programming, microservices, pair programming, domain-driven design, thinking about security. How does that help? After 20 years of software development, I think I finally figured it out. I think I found the one key, the secret to all of quality, the thing that makes a 10x developer or a good architect or a great team lead or a high-level individual contributor. It's not a programming language. It's not a certain natural process. The good news is you can get it. The bad news is you have to keep getting it and getting it. The golden key to excellent software is a strong mental model of the system in context. We need a deep understanding of the system we work on, how it works, and how we want it to work. With the technology, sure, we need that, but bigger. How does our system work in the business? How does it fit into the life of a customer? How does it integrate with all the other software? And how does it work with us in a sympathecy with our team and our automations? The flow from our heads to deployment to results. But Jess, you might say, of course we need to understand the system we work in. Duh. But you don't. You never will. You can't. Because the complexity of the business and the customer and the software and the technology and the other software, it's too much. We'll never fully model it in our heads. This model is never something we can have and keep. It has to grow and keep growing. We're constantly updating it. This is not easy, but it is powerful. Understanding leads to quality in all its forms. Of course, if we don't understand it, if we have a muddy mental model, then we make bugs, mostly in the category of, I didn't know I needed to look over there. But more than that, good understanding makes the customer experience. The customer wants to enter a credit card so that they can pay. If I know how credit cards work, then I can tell them if they mistyped it by one digit. There's a checksum for that. Understanding where the customer is, are they in a public place maybe? I can hide some of those digits. Understanding that this authorization might take a while, I can bring up a loading screen, and that's responsive. Understanding that What we're selling is a big purchase that won't ship yet. I can warn them that a debit card can keep a hold on funds in their account. Understanding the confidentiality of that data means that if we have to store it, I'm going to put that in a separate service. I can find the boundaries. Boundaries are the only hope we have to craft a piece of the system that we can get a mental model of. This is what microservices were made for, to try to give us a small enough piece of software that we could model in our heads. But don't forget, we need to understand the inside and the in-between, the meaning of what passes back and forth. So how do we build that mental model? Engineering disciplines! Done in the spirit of their invention, these lead to understanding. Clean code reflects our mental model back to us when we return to that part of the program. Test-driven development makes us say what the code should do before we make the code. And it makes us make boundaries. Refactoring says, I update the code to reflect my current understanding and then change it. Functional programming lets us know what the code will not do within boundaries. Domain-driven design is my favorite discipline because it goes directly for understanding among the business, the developers, and the code, understanding of explicit boundaries and the meanings that pass between them and within them. Thinking about security. Starting from security leads me to questions that lead me to deeper understanding. What's in this string? 16 digits? Any 16 digits? What's the meaning of that? How sensitive is this data? Do I need to store it? For how long? What errors can happen? This pushes me to a deeper understanding of the system outside and inside my software. In the end, we create software out of understanding. The code is only as strong as our mental model of the system in context. Aim for that, and quality will be yours.